Hi folks, it's Sammy Osmond here from the Climate Action Reserve. Just like to welcome you all to our public comment webinar for our Adipic acid production protocol development process. It's a little bit early. We might pause for a couple of minutes just to let any late attendees register that have registered to join in, and we'll kick things off ostensibly in just a couple of minutes time. So welcome. All right, folks, welcome. Again, it's Sammy Osmond here from the Climate Action Reserve. Just like to welcome you all again to this public comment webinar for our Adipic acid production protocol development process. Looks like we've got a few people logged in. A number of others registered that haven't joined us, so we can expect more to join in a minute, but I think we can start the process now. So just to start with a little bit by way of housekeeping, all attendees are in listen-only mode. Feel free to submit questions anytime in the GoToWebinar question box. You'll see a little user interface, which is typically in the top right-hand corner. You click on that little red arrow, it'll pop out, and then you'll see there's usually a couple of drop-down menus. On mine, right down the bottom, there's a chat function, and then a couple of rows up, there's a question box. So either of those are fine, but if you put it in the question box, our staff will keep an eye on those. So if we have time, we can circle back and take a look at the questions at the end of the session, and certainly we can follow up by email to answer any critical questions that we don't get to address during the meeting. So please do feel free to put questions in using that function. We'll also show you our contact details at the end, so you're very welcome to submit questions via email. And as usual, a recording of the presentation as well as a copy of the slides will be made available to anybody who'd like to post those online to our website. So you can either go there and grab a copy, or you can reach out to us and we'll provide the same to you. In terms of agenda, in a minute, I'll invite my colleagues at the reserve to say a quick hello. It's been a little bit of a change in staff on this development process, so we'll introduce ourselves. Then from there, we'll move into a little bit of an overview of the process itself. So just remind you of the steps we've taken to get us to this point, to put this into context of the total development process and what to expect next. From there, we'll get into a little bit by way of background as to why we're building this protocol, short background there, and then we'll move into an overview of the protocol itself. So that's where we'll hone in and go through all the critical elements of the protocol itself. From there, we'll circle back to the little bit of an overview of the process and just focus in on the critical next steps, reminding you about the public comment period and providing you with our contact details to get in touch. So let's get into a little bit by way of introductions. So first we have Craig Ebert, President from the Climate Action Reserve. Would you like to say a quick hello, Craig?
Thanks, Sammy. Yeah, on behalf of the Climate Action Reserve, I'd like to thank all of you for participating today. You know, a critical hallmark of the work that we do is to conduct our work in a very transparent public engagement process to allow everyone to see from the very beginning of the project until its end how the protocols are evolving, and to make sure that all stakeholders have an opportunity to weigh in. And that's only possible by the contributions that all of you are making. That's why today's public comment webinar is very critical. And again, I thank you all for participating. It is very much appreciated, and looking forward to receiving any additional comments on this particular protocol. Sammy, back to you.
Great, thanks, Craig. So I've already introduced myself, but again, my name is Sammy Osman, Policy Director. So yeah, very much appreciate you all tuning in today. Looking forward to any feedback we receive. John, would you like to say a quick hello?
Yeah, hi everyone. This is John Romacall. I'm Senior Manager at the Reserve. I've been supporting the drafting of this protocol, and I look forward to receiving your feedback.
Thanks, John. Sarah, would you like to say a quick hello?
Hi everyone, this is Sarah Westcott. I'm a Senior Manager at the Reserve as well, and looking forward to engaging with everyone.
Thanks, Sarah. And Heather?
Hi everyone, this is Heather Raven. I'm a Senior Project Coordinator, so I've been helping to coordinate the development process for this protocol and try to answer some general questions any of you may have. Thanks.
Great, thanks, Heather. You all managed to successfully mute your cats and whatnot, so that went well. All right, let's get moving into the process overview. So for those of you who haven't been tracking this from the start, I'll give you a little bit of an overview of where we started off. So back in summer of 2019, we started off with some internal research and scoping that went on for quite some while through to winter 2020. From there, we officially kicked off the process with a scoping meeting. So that was on September 17th. From there, we commissioned an issue paper, some in-depth research on some of the critical issues. We'll touch on a little bit of that when we go to the background section. And from there, we convened our work group. So with all our protocol development efforts, we pulled together relevant experts to help inform the development of the process. So here you can see we had several meetings with those work group expert members to elicit their feedback. Last one being June the 30th. And in essence, we've made significant revisions to the draft protocol based on that work group feedback. And that's continued right through until just a couple of days or weeks ago. So right through until August of 2020. As you can see here highlighted in red, we've taken this protocol out to public comment. The critical part of our protocol development process is to transparently put this material to the public. So not only do we capture the expert feedback from our work group, but we make this information available to everybody. And we certainly very much welcome the feedback from all members of the public to help inform this process. That will carry through until the end of August. And then we'll we'll come back to that in a slides towards the end. But a finite period of time where we very much welcome members of the public to provide feedback, and we respond in writing to all written feedback that we receive. From there, typically we will look to make revisions based on that feedback, depending on the nature there. Quite possibly we will refine and improve things based on your feedback of the public. And we anticipate that to go through to September. If we need more time, we can take it. But that last dot point there, the last point in our protocol development process is for us Reserve staff to present the final protocol to our board and to invite them to adopt it. So the next available opportunity we have to do that is on September 30th. So that's the clear goal here, to wrap up this process and bring it to our board by the end of September. So now we'll touch on a little bit by way of background. I think most of you on the webinar today are probably pretty familiar, but we'll touch on this nonetheless. So essentially, adipic acid is among the top 50 synthetic chemicals annually produced in the US. One of the largest demands for it is in the manufacture of nylon. Nitrous oxide is generated and emitted as an unavoidable and an unwanted byproduct of that production. So adipic acid N2O abatement or control technology can be installed downstream of where the reaction occurs to treat the facility's off gas. So in the US, there are currently 2 adipic acid production facilities. Both of them are fitted with some form of abatement technology, though only one of those facilities is legally required to abate N2O based on facility-specific conditions. So nonetheless, there are significant potential opportunities to voluntarily abate further N2O, and typically significant costs associated with doing it with little to no incentives. So that's where offsets fit in. We think there's a good opportunity to provide offset revenue as an incentive to further voluntary abate N2O. A little bit by way of international offset project history. So the UNFCCC's Clean Development Mechanism is an offset protocol, offset program that's run by the United Nations program. There was a methodology specifically addressing adipic acid production. Projects installed catalytic or thermal N2O destruction equipment at the facilities, at existing adipic acid production facilities. And based on that experience, there were some concerns raised in the international community. In particular, there was a concern that production shifted. In other words, we call that market production shifting leakage. So production shifted from plants that weren't running these offset projects to the offset project plants, and it resulted in an over-crediting and a generation of offsets that were considered to be not beyond business as usual. One of the key problems there was that that protocol and that program essentially set baseline N2O abatement emissions at 0. So they assumed no historical abatement was going on. And so that led to a huge production of offsets that was not reflective of current practice or baseline conditions. And another problem that was observed was that the value of the offsets in that specific context in particular far exceeded the value of the adipic acid itself. So it created a perverse incentive to overproduce adipic acid. And this caused, or seemed to cause, a substantial shift in worldwide adipic acid production from non-project plants to the plants where the offset projects were running. And eventually that led the EU to ban the use of these offsets from its carbon market. So as we'll show you in a few moments, a number of these critical underlying conditions are not present in our program, most specifically setting the baseline into abatement levels at 0. We will not be doing that. A little bit more by way of lessons learned. So in order to combat that key risk, one of the most straightforward and efficient ways to effectively reduce the risk of leakage is to set the baseline emission benchmark. In other words, emissions per adipic acid production. Set it based on actual historical conditions at the plant in question, rather than setting it at 0. So only emission reductions that go beyond the benchmark would be credited, i.e. you multiply the amount of adipic acid production eligible for crediting with the baseline emission factor. You still provide considerable incentives for the industry to go beyond what they were doing historically for those facilities in particular. A little bit more by way of some other CDM style projects there. So JI is simply joint implementation. It's another offset program that was similar to CDM in a slightly different part of the world. So there were similar concerns that were raised there. But in essence, the carbon market provided incentives to innovate and implement highly effective N2O abatement solutions. So that's what we're hoping can happen here in the US. We'll now move over to an overview of the protocol itself. And I think we'll hand over to Sarah at this point.
Thanks, Sammy. So I'll be covering an overview of the protocol structure and some of the basic requirements, beginning with project definition and eligibility. So this protocol credits for reduction in nitrous oxide emissions at adipic acid plants relative to their baseline levels, like Sammy mentioned. And we have two options for adipic acid plants to meet the project definition. One is the installation of a new N2O abatement technology that has not been used at the plant. And the other is an upgrade or enhancement of an existing abatement technology that results in further reduction of N2O compared to the baseline. And what we mean by enhancement is really any investment into the existing technology that would improve its efficiency compared to historical levels. And this project type is only going to be eligible at existing, relocated, or upgraded plants. So this would not include new plants. To expand on what we mean by N2O control or abatement technologies, we're really talking about a few options here. You can destroy N2O using selective or non-selective catalytic reduction. Destroying N2O by burning with methane or natural gas is also eligible. And then N2O can also be recycled to create nitric acid or recycled to create other chemical compounds. And we are open to reviewing new or emerging control technologies that could potentially be used with our approval, but we expect this list to adequately cover what most projects would be looking at using in the near future. The eligibility requirements for the protocol follow our standard approach and layout. So first is location, which in this case we are limiting to the United States for this protocol. The next is start date, which is the first day that adipic acid is produced following installation of the control technology or enhancement of the control technology. Projects must be submitted to us no more than 12 months after the start date. And then for this protocol, we'll be looking at a 10-year crediting period with a possible renewal for a second 10-year period. We have our standard performance standard and legal requirements test. Both of these ensure additionality, and I will get into these a little bit more on the next couple of slides. And then lastly, all projects must be in compliance with all relevant local, state, federal laws and regulations. Our performance standard test for this protocol is technology-based. So like Sammy mentioned earlier, there are some financial barriers that are inhibiting further abatement of N2O. So installation of one of the technologies we listed or an enhancement of an existing technology goes beyond business as usual and would be considered additional. And then research put out by the Stockholm Environmental Institute around costs for operating these plants and expenses related to the control technologies just further reinforce this assertion that there is a financial barrier preventing these technologies from being installed. Projects pass the legal requirements test as long as there are no legally binding mandates to abate N2O at the plant. To date, we have not identified any such mandates. However, it's worth noting that the Clean Air Act requires abatement of NOx, and this can actually sometimes result in reduced voluntary abatement of nitrous oxide. Typically, the Clean Air Act does not require any nitrous oxide abatement. However, in cases where the tailoring rule is triggered under Title V, PSD permits may require an assessment and potential installation of best available control technology or BACT. So if at any point we have an adipic acid project that has any sort of abatement technology that becomes mandated as BACT, then the project would cease to be eligible for crediting. But we see this as probably being an unlikely scenario. The primary SSR we credit for is SSR1, or the nitrous oxide emissions created and lost during adipic acid production. This is looked at in both the project and baseline scenarios. And then there are a couple other SSRs that may be applicable in certain situations. So SSR3, if hydrocarbon inputs are used for the project, then the associated CO2 and methane emissions are accounted for. And if there's any sort of steam export, off-gas utilization and heating, or fossil fuel and electricity use, then we would also account for associated emissions with those. And then Sammy, I think I'll pass it back to you now.
Great, thanks, Sarah. So now we'll get into a little bit of the quantification approach. So we'll start with the baseline. We'll go through a couple of, there are multiple baseline approaches available here, and then we'll move into the project level accounting, the project side accounting. So in terms of quantifying baseline emissions, essentially baseline emissions are quantified using facility-specific N2O abatement efficiency levels. And those in turn will be based on the quantity of N2O in the off-gas remaining after baseline voluntary N2O abatement. So this ensures the baseline is conservative and representative of only the incremental emissions reduced beyond what was already being voluntarily destroyed in the baseline at that specific facility. For added flexibility in this particular protocol, we're going to allow project developers two options for setting their facility-specific baseline N2O abatement efficiency levels. There is a static baseline N2O abatement efficiency level or approach, or there is a dynamic baseline approach. The dynamic approach changes each reporting period based on the historical maximum and minimum abatement efficiency levels, as well as historical maximum and minimum adipic acid production levels, and compares those to current adipic acid production levels. So on the following slides, we'll go through each of those approaches in a little bit more detail. In terms of the static baseline approach, basically we'll create a value which is a static baseline abatement efficiency level. So that will be done through a number of those steps listed in the first few bullets there. So first we'll calculate the average annual abatement efficiency over a static baseline look-back period. So we'll first calculate annual abatement efficiency values for each baseline years using all available data. Next, we'll calculate the mean abatement efficiency value over the entire baseline period using those annual AE values. From there, we deliberately introduce conservative bias by eliminating any annual AE values that go beyond 2 standard deviations below the mean over that baseline period. If any single annual AE values fall 2 standard deviations below that mean, they will be removed and replaced with, each of those will be removed and replaced with the single annual AE value over that baseline period that has the highest average AE. Once that's done, we recalculate the mean AE value over the entire baseline period using those replaced annual AE values. What do we mean by the baseline look-back period? So here we've set that the baseline look-back period must be the most recent calendar years of operation prior to the project start date, and they must date back to 2015. So we must use all available data from 2015 forward, essentially, through to the project start date. So we're using, using data prior to 2015 was deemed as inappropriate due to significant structural changes in the US adipic acid production industry around 2015. So just by way of example here, if a project starts this year, they'll essentially be using 5 years of historical baseline data starting in 2015. If the project was to start next year, they'll essentially be using 6 years of baseline data, etc. Annual baseline AE is essentially the percent of the AAP's N2O emissions that were destroyed by the N2O emissions control unit in a given historical year within the static baseline look-back period, calculated by dividing the amount of N2O reduced in a historical year by the total amount of N2O emissions generated in the same historical year. And this will rely on direct historical measurements using SEMS data. Here's the equation for quantifying the baseline GHG emissions. We'll get into leakage a little bit later, but you'll see that's the LD right at the bottom there, proportion of adipic acid production in the reporting period. I'm not going to go through this equation in detail, but it's here for your reference. Now we'll move over to the dynamic baseline approach. So in order for the baseline to be dynamically tied to the amount of actual N2O emissions created by an adipic acid facility in the production reporting period, the facility-specific baseline abatement efficiency must be multiplied by total N2O emissions in a given reporting period prior to any abatement. So the abatement efficiency is dependent on maximum and minimum baseline N2O abatement efficiencies over the dynamic baseline look-back period, maximum and minimum baseline amounts of adipic acid production over that same baseline look-back period, and the amount of adipic acid production in a project reporting period. So the dynamic baseline look-back period is set using data back to 2015, the same as the static alternative. In other words, projects starting this year will use 5 years worth of data, projects starting next year will use 6 years worth of data, etc. In terms of trying to develop this correlation, projects must demonstrate an appropriate statistical correlation, i.e. a minimum R² of at least 0.8. And in the protocol, we provide guidance to project developers to reach out to the reserve as early as possible when trying to put together such an analysis. In essence, it will need reserve approval. So the earlier they engage, the better. As Sarah mentioned, there is also the possibility of nitric acid recovery. So that's something we account for in this protocol. Nitric acid recovery is a function of N2O conversion to NO, which is then converted to HNO3 downstream in the process. So in essence, this applies to recycling technologies that can convert a portion of the N2O in the exhaust to beneficial byproducts rather than simply oxidizing the N2O to nitrogen and oxygen. So these calculations in the protocol establish a baseline average and a project ratio for nitric acid to adipic acid, and then the nitric acid ratio is the average of nitric acid to an average of adipic acid over the baseline look-back period, less the ratio of nitric acid to adipic acid in the reporting period. Leakage, I think Sarah is going to be picking up here to take us through leakage.
Yeah, thanks. So as we talked about earlier in giving the background for this protocol, preventing and accurately accounting for leakage is a key concern here. If offset revenue shifts adipic acid production to the project facility, it risks us crediting for N2O abatement that may have occurred elsewhere had the production not shifted. So in this protocol, we're offering 3 approaches to address leakage, which I'll talk about on the upcoming slides. Our first approach focuses on adipic acid plants that operate under a common corporate umbrella in which there are multiple adipic acid plants. So in this case, the project would calculate the average annual factory loading, or the percent of the plant's production capacity being used during the baseline period relative to the reporting period. If this decreases at other adipic acid plants and increases or remains steady at the project, we'll discount for leakage by reducing baseline emissions by the percentage of increased adipic acid production. The second approach is for a project plant that is just a singly owned adipic acid plant that is not part of a corporate group with multiple plants. So in this case, the project must conduct an analysis of publicly available market information and assert why leakage has not occurred. If they cannot do this and adipic acid production has increased, then similarly, we will reduce the baseline emissions by the percent that production has increased. And then our third option is if for any reason the first 2 options cannot be used, then we will assume that any statistically significant increase in adipic acid production constitutes leakage. And so in this case, we'll look to the Clean Air Act Title V permitted production levels as of the project start date, and that will be used as a production cap to essentially put a ceiling on the baseline emissions. Equation 5.11 is the final equation for calculating project emissions. So as stated earlier, this includes the 3 SSRs. N2O emissions will always be included. CO2 and methane associated with hydrocarbons will be relevant if hydrocarbons are used in the project control technology. And then greenhouse gas emissions for external energy use for reheating off gas are also going to be accounted for if applicable during the reporting period. Lastly, I'll touch on project monitoring, reporting, and verification, or MRV. Projects will employ a monitoring plan, which serves as the basis for verification. This is standard for most of our projects. And most data for this project type will be monitored and reported via a continuous emissions monitoring system, or CEMS. So CEMS installation and QA/QC are detailed in the protocol, but essentially they follow the Code of Federal Regulations requirements for these systems, and missing data substitution similarly follows those requirements. And then lastly, Table 6.1 of the protocol provides a comprehensive list of all parameters that are required for project reporting. Projects calculate their emission reductions over a length of time that we call a reporting period. Once the project has commenced, there cannot be any gaps in reporting, and we do provide some flexibility in this protocol in terms of reporting period length. We do not mandate that the reporting periods align with calendar years, but a minimum of an annual site visit verification is required. So each reporting period has to be verified, and the plant has to be visited by a verifier at least once per year.
Great, thanks, Sarah. I think that's pretty much it for the protocol overview. So we'll take folks into next steps. We touched on those earlier. We'll recap. So just a reminder, the protocol is currently out for public comments. That started at the beginning of August, and that goes through till August 31st. So we do welcome all members of the public to submit comments by August 31st. We request that they be submitted via email, preferably in Word format. There's a policy email contact address there, so please do feel free to send those in if you're interested. Again, we do reply in writing to all public comments that we receive. So this is a critical, transparent part of our development process. And then from there, depending on the nature of the feedback, quite often we will make adjustments to the protocol to make improvements based on such feedback. And then again, our next available date to present this to our board and invite them to adopt it will be September 30th of this year. So we do hope that we'll be able to bring the protocol before our board on that date. Contact details. Any questions you have about the protocol development process or technical aspects of the protocol itself, please do feel free to reach out anytime by the email address here. Feel free to do so informally. There's no need for you to submit formal public comments, though you're most welcome to do so. If you'd like to submit informal comments, please reach out anytime. If you'd like to engage with staff via a phone call, that's also very welcome. Reach out via email and let us know. We'd be very happy to sit down with you and talk through any of your feedback. And that's it, ladies and gentlemen. So it doesn't look like we have any questions in at the moment. So again, we'd like to give a big thanks to each of you for joining us today, and we look forward to any engagement that you care to make with us. And yeah, great. Thank you very much, folks.